All right, good morning. My name is Ryan Bertrand, and today I'll be discussing the impact of control engineering on our quality of life. All right, so what is control engineering? It is the field that ensures systems behave the way we want them to. It uses sensors to measure what's happening, feedback loops to compare the real output to the desired output, and controllers to adjust the systems accordingly. This discipline is foundational to modern technology, enabling precise and reliable operation across countless applications. All right, so some everyday examples of control systems are um, thermostats, cruise control, washing machines, and refrigerators, etc. And whether we notice it or not, control systems operate around us constantly. A thermostat adjusts heating and cooling to maintain comfort. Cruise control keeps a car at a steady speed. Washing machines and refrigerators use sensors and internal control logic to run efficiently. Even our smartphones use control engineering principles to optimize battery charging and power usage. All right, impact on safety. One of the greatest contributions of control engineering is improved safety. In aviation, control systems stabilize aircraft and support autopilot functions. In vehicles, technologies like ABS and electronic stability control prevent accidents. Industrial machines use control systems to avoid dangerous operating conditions, and electrical grids rely on automated protective relays to detect faults and prevent large-scale outages. All right, impact on healthcare and medicine. So control engineering has transformed modern healthcare. Devices like insulin pumps regulate blood glucose precisely. Ventilators rely on closed-loop control to maintain safe airflow and pressures. Robotic surgery systems use precise actuation for minimally invasive procedures. Even, even medical imaging such as MRI and CT rely heavily on complex control algorithms. All right, so for environmental and energy benefits, control engineering enables more sustainable living. Sensors and controllers optimize HVAC systems to reduce waste. Smart grids balance renewable energy sources like wind and solar. Modern vehicles use closed-loop emissions control to minimize pollutants. Even water treatment plants use advanced automation to ensure clean water and minimize chemical and energy use. All right, so in transportation, control systems make movement safer and more efficient. Autonomous vehicles rely on control algorithms such as steering, braking, and lane handling. Trains use advanced control for smooth braking and speed regulation, and drones stay balanced thanks to real-time control loops. Even city traffic lights use control logic to reduce congestion and travel time. All right, so when it comes to comfort, convenience, and productivity, control engineering makes daily life more convenient. Smart homes automatically adjust lighting and temperature. Automated manufacturing increases product consistency and reduces human workload. Warehouses use robots to move efficiently. Even farms use control systems for irrigation, fertilizer, application, and harvesting. All right. So at a societal level, control engineering underpins reliable power, clean water, healthcare systems, manufacturing, and communications. It reduces costs by automating processes, improving product quality, and enables industries like aerospace, automotive, telecommunications, and renewable energy. Ultimately, it raises global living standards. All right, so the future trends in control engineering. The future of control engineering is even more transformative. AI-driven predictive control systems will allow machines to adapt faster and more accurately. Autonomous vehicles will reshape transportation, and smart grids will integrate renewable energy seamlessly. In industry, humans and robots will work side by side safely, and personalized medical devices will offer tailored therapies. All right, so in conclusion, control engineering plays a direct role and powerful note in improving our quality of life. From safety and health care to comfort, energy efficiency, and transportation, control systems make modern life possible. As technology advances, the influence of control engineering will only grow. Thank you for listening. So on the real, at LyondellBasell, for controls and control engineering, they use something called a delta V. And for real world experience, that has shown me a lot to how useful this can be and why this should be truly studied further. For Winchester, instead of using a distributed control system like Lyondell does, they use PLC programming, programmable logic controllers. And the main difference between those is when you want to use PLC, you want to be faster, or you need it to be faster, and it works a lot faster. Versus the DCS, you would use that if you want to control everything on one, we'll call it a system, but it doesn't have to all rely on each other. I just wanted to say that is my experience with control engineering so far, more of the application rather than designing. So here are my sources/references, and this concludes my PowerPoint.